I think we can start. I'd like to welcome you to the second talk. This is the solutions talk, so we're looking forward to this. As we said before, please mute yourself. There is a chat if you wanted to ask questions. And I also wanted to remind you that this is going to be recorded. The part one is available on the Embankment's YouTube channel as well as on our website. In the list, the link is on the event section of our website at embankment.org. So I would like to introduce Peter Delman, who's treasurer of the Embankment Preservation Coalition, who will do the introduction of Dr. Baker.
Hi, I'm Peter Delman, a founding member of the Embankment Coalition and current treasurer. Welcome to our talk on the challenges of climate change in 2021. Dr. D. James Baker will be presenting tonight, so thank you, Dr. Baker. Dr. Baker is a physicist and oceanographer who has served in many academic, nonprofit, and governmental positions. In the Clinton administration, he was the head of the National Oceanic and Atmospheric Administration, or NOAA, and later served as the director of the Global Carbon Measurement Program at the Clinton Foundation, specializing in reforesting programs in developing countries. Currently, he's advisor to a company based in Australia that develops forest management software. This evening, Dr. Baker will focus on solutions to what has been called the existential crisis of our time. There will be a Q&A period at the end of the program.
Okay, shall we start?
Yeah.
Okay, thanks, Peter. And hello, everybody, and thanks for joining again. Tonight, we're going to focus on solutions. In my view, the most interesting and exciting of the issues relating to climate change, but not just interesting. In fact, the Biden administration has taken on this issue head on. So there's a lot of exciting things happening. In fact, so much so that I kept adding things to this talk up till this morning and finally had to stop. We're going to focus on what society needs to do, what is happening, and then what individuals can do. So let's just remember, and for some of those who may not have heard the last talk, we talked about the impacts of climate change and warming from carbon dioxide, and we finished up with a discussion of the Paris Agreement, which was in December 2015, focused on the fact that if we didn't do anything, we would have a temperature in 2100 of at least 5 degrees Fahrenheit. But the Paris Agreement said, let's try to limit that to 4 degrees, and if possible, try to limit that to 3 degrees. And each nation put together a plan to show what it would do to try to limit to either 4 degrees or 4 degrees, how it would limit carbon emissions. And let's see how they're doing. This is a result from a study that MIT did. The red line plus the pink areas around it is what the carbon emissions would be if nothing were done. In other words, if we had business as usual. The purple line is what emissions would be if everybody followed what they promised to do in Paris. It's not that different. You can see emissions still rise. So even though nations agreed to try to limit their emissions, what they have agreed to so far is not really enough to drop emissions below the level where we would have dangerous climate change. In fact, we need to drop them either to the blue curve, that would give us about 4 degrees Fahrenheit, or to that green curve, which requires some drastic drops in order to limit to 3 degrees. So you see, there's a big difference between what countries have agreed to and what we really need to have. And so we're going to look today at how do you fill this gap, this what we call emissions gap? Just to emphasize that, let me go back here one. Just to emphasize that The red and the purple are what is going to happen if we either don't do anything or we follow what nations have currently agreed to do. That is temperature continuing to rise. In order to get this temperature leveling off, either at the blue or green levels of 4 degrees or 3, we have to reduce emissions, just to emphasize that point of reducing emissions. What do we need to do? Well, 4 points. We finished up our talk last time with these 4 points. We need to embrace carbon-free energy, capture the carbon, put a price on carbon. Economists always say if you want something scarce, put a price on it. And then to the extent we can't accomplish those things, we're going to have to learn to adapt. So let's look at each of these 4 areas here. In terms of embracing carbon-free energy, you know and are familiar with the need to support solar, wind, and hydropower. We also have to look at whether nuclear fission can play a role, plays a small role today. We need to electrify as much as possible so that we can use renewables. To electrify, we're going to need a new grid that can handle solar and wind with intermittent power, lots of batteries and other kinds of storage. And then in particular, as you listen to this, think about the fact that most of the energy growth in the world is going to come from the need of developing countries. And we've got to provide ways for them to get energy that does not have carbon emissions. So that's a key element. Let's look at each one of these in turn. Solar and wind, you're familiar with these. They're growing. Still, the total covers about 10% of the total energy need that we have. And each solar and wind, they take a lot of area. So this is something that has to be worked on. But in fact, solar and wind are providing in some areas, providing even 100% of energy. Here's a picture I just got from April from last month. California actually reached 100% renewables for part of the day on April 24th. Didn't have to import any energy from coal plants outside California, and we're able to do everything with renewables for a short time. So this is the kind of thing that we want to have happen over a long period, but California was able to achieve it, at least for a short time. So it emphasizes the needs for batteries and getting into the renewable world. Well, one of the pieces of this is electrifying transport. We've got to have electric cars, and every major auto manufacturer today has an electric car line. It's not just Tesla, but it's not just cars, it's buses, it's rapid transport. And even to the extent that we can do it, we've got to find a way to electrify ships, and hopefully we can do that with aircraft. Here's an example of where we are with those. We're not ready to have long distance air transport by batteries, but in fact, there's a small Cessna that can take 10 people 100 miles on about 1 ton of lithium-ion batteries. So that's an electric powered Cessna there. And then down on the right is the Emerald Ace, the first partially renewable driven ship from Japan. It is completely carbon free when it's in port, not actually running. When it's running out in the ocean, it's diesel powered, but it's a start. It's the first step towards renewable energy driving ships. And then you've probably seen the postcard from Mars that shows that even on Mars, they've got electric airplanes, electric helicopter moving up from the rover there. So that's a direction that I think the next generation is going to be providing a lot of inventions for. Residential buildings is another important area for us to look at. Buildings account for about 8% of emissions, so it's not negligible. But in New York City, nearly 70% of the city's total carbon emissions come from buildings. So the more that there can be insulation, and you can use wind power, the Empire State Building, and all of the ones run by the company that runs the Empire State Building are powered by wind. Here's a picture on the left of energy storage and roof garden building that was retrofitted in Rotterdam. So this is an active activity going on now around the big cities, trying to find ways of insulating buildings and getting renewable energy into buildings. Important part of what is happening. We also need to look at a nationwide smart grid that can accommodate renewable energy. Accommodating renewable energy means you've got to have some battery storage or some other kind of storage. In fact, batteries are clear what they do, but one of the things that's being pushed today is not just electricity, but gravity, electricity, gravity. And the way you do that is you have a heavy weight. When the wind is blowing or if the sun is shining, you've got power, you can lift the weight to a top of an old mine shaft. And then when the wind is not blowing, you let the weight down, it spins a generator, and you can generate electricity. So a very simple kind of battery or energy storage that certainly will be part of any new energy system. And then just a note, that in Brooklyn, there's an interesting new example of homes that are sharing renewable power. There's a microgrid. People who own solar panels are sharing electricity with those who don't own it, and it's all being accounted for by a blockchain technology. So it's a nice and straightforward about how it works. More of these microgrids in place would really help. If you might even think about putting one of these in your own neighborhood. So these renewables have to be added to the grid. Well, you know, if you look at a map of the United States, you can see the solar is most prevalent in the southern part of the country. We have three grids. We have an eastern and a western and a Texas grid. You remember hearing about the Texas grid with the big freeze a couple of months ago. Wind is more prevalent right in the sort of mountainous regions of the country. And so you have to accommodate all of these and at the same time find a way to make sure that if one part of the grid goes down, the other parts are not affected. In the end, you need something like this, a new national grid for the US that involves wind, solar, natural gas, hydroelectric power, and even nuclear power to the extent that it can be put together. But the importance, and this is a key point, the importance of having a national grid is that the grid is bigger than any single weather system. So if the wind is not blowing in one part of the country, it will probably be blowing in another part of the country. And if those are both connected to the grid, then you don't have to worry about these fluctuations in the wind. So that's a way of making this work. And the current discussion is a national grid, maybe run along the interstate highway system. But you can see, once again, a lot of interesting new ideas about how we can distribute energy, and particularly renewable energy. Well, just to say a word about nuclear fission, the big question is, can we make this safe and acceptable? Obviously, there was a huge disaster at Fukushima with the tsunami and a poor design of that reactor. We've seen costs continue to rise as renewables get cheaper, nuclear is more expensive. Plus we have the problem that the waste products, we don't know exactly how to deal with them, and they can be used for nuclear weapons. So a lot of issues with nuclear power. The technologists say that this is something that could be useful. Maybe we can have small modular reactors that are safer. I would say the jury is still out on nuclear fission. Today, it's about 10% of world power. There are some countries like France that have as much as 80% nuclear, but that has actually been declining these days. So as I say, the jury is still out on nuclear fission. So that's renewables. Let's look at the second part of this discussion, which is capture the carbon. One thing to do is fix the leaks and plug the wells. Most old abandoned oil wells are not plugged and are still leaking methane. So if we could just spend the money necessary to plug the wells, that's a major step forward. And if we could replace old methane natural gas pipes with new piping, then we could have less leaks of methane. Here's a picture done by the Environmental Defense Fund, Staten Island versus Indianapolis, measuring the methane with Google mapping cars that have methane detectors on. They drive around and check for the methane, and then they have satellite data that also looks at that. Comparing Staten Island to Indianapolis. Indianapolis has a new methane natural gas system. Staten Island is old, and you can see the difference here. So fixing the leaks, plugging old wells, and of course, simply using less energy is also a way to put less carbon in the atmosphere. So that's also helpful. Another way to capture carbon is to plant trees. Trees are really the perfect sequestering systems, already adapted to Earth. And you know, the major carbon is stored in the tropical regions. In the Amazon, there's my red circle, in the Congo, and then in Indonesia. These are forests that need to be protected. And then there are new reforestation programs going on in the north of China. You can see with the green circle there, called the Great Green Wall of China. And then in Africa, there's a program, the Great Green Wall of Africa, that extends from one coast of the continent to another. It's about 6 different countries involved, growing trees and shrubs in an area of the Sahel that had been degraded, but now helping preserve this and providing new jobs. So there's active reforestation efforts going on. And in fact, there's a global reforestation effort called the Trillion Tree Initiative that aims to double the number of trees on Earth. There are about 1 trillion trees on Earth, and this would double them. Well, where does that carbon go? It's not just in the trees. It's not just in the leaves and the trunk, but about half of the carbon in trees is stored in the roots. You can see that 13%, and in the soil, 45%, 58% of carbon in a tree is below ground. And so it's very important that we protect the soil, which is also important, of course, for farming. But I mentioned some thing I just saw this morning. Here's a new exhibit that Maya Lin has put together called Ghost Forests. She's taken Atlantic white cedar that were killed by salt intrusion from the New Jersey pine barrens. You're all familiar with that. Taken those trees, transported them up to Madison Square Park, and she's got them erected. And you can see that exhibit is going to run through November. Ghost Forest, just trying to remind us of the importance of saving trees. So I mentioned soil. Soils are obviously important for agriculture. We need to have no-till plowing for crops. We need to make sure that we're doing the right thing in terms of improved grazing management with support for clean water, rotational crops. So there's a minimum of nitrous oxide, which tends to come from the soil and from fertilizers, nitrogen fertilizers that are added. And of course, one of the new things is try to apply biotechnology to this. New biotechnology can build microbes that deliver nitrogen directly to corn on demand from the roots. They see the signal, they deliver the nitrogen. This makes it much more efficient in terms of delivering nitrogen. It means there's less left over that can escape into the atmosphere. And so it means that agriculture is less of a factor in terms of producing the greenhouse gases that are responsible for global warming. And then if you think about far out ideas, new biotechnology techniques are actually available to take carbon dioxide that's in the atmosphere, add water, and to make liquid hydrocarbons, new kinds of hydrocarbons that could be transported with the existing fleet of ships, hopefully operated in a green way, and distributing these out to developing countries that need green energy. Whether this can be done or not is a good question. It's an idea, and we know that in technology, many times an idea can actually be made reality. Well, let's just look at a quick summary of some of these ideas. Obviously, some solutions are cheaper than others. Here's a chart that was made, and we can provide this out to everybody to look at in detail. Cost goes up on the graph, and the actual abatement or the ability to store carbon, save carbon, goes off to the right. So the most expensive but the most effective thing that we can do right now is to retrofit coal plants in terms of the economics, as it turns out. The cheapest thing to do, but the least effective really, is to replace the lights in your house. It's a good thing to do, but it only has a small effect. And then in the middle, you can see hybrid cars, crop management, wind and solar. You can get a sense of what is cost effective and what has a good impact. Obviously, there's a range of these things, and when society decides what to support, it's this kind of graph that helps you make that decision. Well, the third point, I had 3 points here. What is the third point? Put a price on carbon. The question is, what is the price? It's the social cost of carbon, which includes the impacts. In other words, how do we fold in future impacts of using carbon into today's cost? The economists will call this the discount rate. If there's a big impact, but it comes later, you're going to have to incorporate some of that cost into what we do today. We know from all of our discussions so far in the first talk, there are going to be impacts on public health, on agriculture, water supply, property damage, species extinction, a variety of different impacts on society. And so today's emissions also have a long-term effects. Carbon lasts in the atmosphere for almost 1,000 years. So you have to pay more now in order to help alleviate these effects. The Obama administration worked out what would be a sensible cost, and they worked out a cost of carbon which would be about $51 per ton. The Trump administration took the opposite view. Their view was, we really don't have to worry about long-term effects. Let's just charge the cost of extraction from the ground and delivery, not any of the impact effects. They dropped the price down to $8 a ton. You can see a big difference there. President Biden has gone back to the Obama administration, $51 per ton. But it's important to note, the more we learn, the more we see that an even higher price is going to incorporate all the social impacts. The more we learn, the more we see that there are important and difficult impacts on society here. Well, let's try to bring this down to some simple numbers. If you look on the left there, you're paying, I don't know what you pay in Jersey City right now, $3.50 a gallon for intermediate grade gas is something like what we pay. If you look in the middle of the graph there, if the price were $100 per ton, that would add 90 cents to a gallon of gas. If it were $50 a ton, that's the Biden number, $50, that would add about 45 cents to a gallon of gas. Are you willing to pay another 45 cents? Well, maybe you are, but maybe the commuter who is on the low end of the economic scale is not willing to do that. So you have to find a way to add this price, but make it equitable across society. But that's the only way that you can really deal with these things on the right, all of these impacts. And this number $51 per ton, which Biden is using, is something that's put into all federal regulations as they decide how they regulate industry and tax industry and so on. This social cost or impact is also useful if we look at impacts around the world. And this is especially interesting map because it shows the social cost of carbon, the impact of use of carbon around the world. And you can see that the orange and yellow and red are the countries that have a positive, or if you want, negative impact. It's going to cost you more to use carbon, whereas the blue countries are ones where the warming, I remember we talked about this in the first lecture, the warming is stronger in the northern countries. The positive impacts from agriculture outweigh the negative impacts, and so these countries have a a positive impact of climate, and so a social cost of carbon is really negative there. Whereas in countries like the U.S., China, India, Saudi Arabia, Brazil, you can see a number of countries in Africa, Australia, Indonesia. All of these are countries that are going to have a problem. But you can see this graph in a way illustrates the difficulty of dealing with these problems worldwide, because you have countries coming to the table. Some countries see a much bigger impact than other countries. And so trying to get everybody to agree to a single number on costs or impacts is not so easy. It's interesting that we've been able to get as far as we have. If you look at the US specifically, you can see that agricultural yields are worse under climate change in the eastern part of the country. Workers who work outside are affected all over the country. You can see that the second from the left there, supply of high risk labor, sorry. And then the mortality is higher in the southern states where the temperature is higher. And I don't know whether you can see it, but on the right, coastal damage is mostly in the southeast and eastern US, where we have low-lying coasts and we have subsidence. If you look at a picture overall for the US, it looks like this. Less impact in the northern regions and a big impact in the southern regions. I wouldn't say it's exactly equal, but in some sense, the regions where you have the most climate deniers are the regions where you're going to be hit most strongly by climate. Maybe this will help people come to a conclusion that you really should be careful about dealing with climate. Where are carbon prices in place today? Well, there's a number of countries. In fact, there are 40 different countries that have put some kind of price on carbon, ranges from about $10 to about $40, so still on the low side. Canada has a price of about $26, and it's growing every year. Europe has a price ranging 25 to 40, something like that. Australia has a price. Brazil, Argentina and Chile have put carbon prices in place. So this is slowly rising. Each year we see another country that has put this in place. So these are the 3 points that need to be put in place in order for us to deal with climate change. If we don't get these in place in time, we're going to experience climate change and we're going to have to do some adaptation. So we ask these questions. Can the transition to carbon-free energy be done in time to avoid dangerous climate change? How do we expand existing infrastructure to maintain our economies in a warmer and wetter world? And what about new infrastructure to protect against new climate extremes? There are a lot of adaptation programs going on today, and let's just look quickly at a few of those. You've probably seen this. In the case of Austria, which is definitely getting warmer, you're getting less snow in the winter. The ski resorts are suffering. You can't do the winter sports that you wanted to do. And so here's one, Sant Corona am Wechsel in Austria, that has moved to become a summer resort, all summer sports. So they're focusing on that, and they were able to get government grants to move to a new kind of economy there. Coffee has been moving. There was a coffee strain that was first identified and used in 1920, which is more resilient to warmer temperatures. That has been neglected because the Arabica coffee that we mostly use from Ethiopia these days in Kenya has been is a very tasty coffee, and it grows in the current climate. But as climate warms, we're going to have to move over to this stenophila, which is the warmer climate. In fact, there's a number of African countries that are currently using that. Here's another example, building barriers. It's much better to build a soft barrier to sea level rise. We know the sea level is rising because the earth is warming and the glaciers are melting. But having soft barriers is much preferable. enables us to restore habitats and to have a managed retreat. You have dunes with vegetation. It's easy for people to get to the beach, but as we retreat with sea level rise, it's easy to make that transition. There's also a big program going on, as you would expect, in Louisiana to try to rebuild the marshlands out at the mouth of the Mississippi River. Here's a program in Barataria Bay that has been going on now for a number of years, building higher marshlands by moving sediment into the green areas, as you can see there. Or you can do the full thing, just move whole cities. Indonesia has made the decision that they're going to move their capital, Jakarta, from the island of Java up northeast about 250 miles to East Kalimantan. They're going to move it inland. Jakarta is currently right on the coast. It's subject to sea level rise, to sinking, and to a lot of pollution. So they're going to build a new city. They're going to try to build it so they can avoid pollution, but they're going to build it further inland so that it is not subject to sea level rise. I don't know if we'll see more of these, but this is the kind of adaptation that we're already starting to see. Now, could we stop this at all? Well, you could do some kind of geoengineering of the planet. This is being discussed. It's all trillions of dollars, so we don't know if it's something that's ever going to be feasible. But technologically, you could build a giant heat shield, build a giant mirror, or many mirrors, put them in space, reflect sunlight. You could add aerosols to the stratosphere. That's what volcanoes do. In 1991, when Pinatubo in the Philippines exploded, the temperature dropped by about 2 or 3 degrees Fahrenheit for about a year and a half, because sunlight was reflected from all the junk that Pinatubo put into the atmosphere. So the thought is, well, maybe we should inject the stratosphere with aerosols to reflect light. The problem with that is that it makes the sky white. I'm not sure people are going to like that. But it also changes the weather patterns. It changes the distribution of rainfall. So maybe we cool things down, but if we change the distribution of rainfall, what happens to all the farmers in India and Bangladesh and Africa who depend on having rain where it is today? So this is not clearly something we can do. And besides, all of these ideas don't stop the CO2 from rising. So the CO2 continues to rise. If you ever stop doing any of these things, assuming you could afford it, you have a huge temperature increase. So this is not really a good idea. So how do we implement a new energy transition? Well, we need public understanding, interest, and advocacy. And that's one of the reasons for a talk like this, is to get people involved and engaged. We need new government policies. President Biden is actively doing this with his White House climate team. We need engagement of the private sector. And of course, there's a huge private sector development in renewable energy, but there's disengagement, if you want, from the oil and fossil fuel industry. So there's a battle that goes on there. We need institutional investment and divestment from fossil fuels. We need research, not so much, we still need research on the physical science, but we really need research on the social science. How do people interact with this global change? We've never had to do that as a society. Peter mentioned, and we'll talk about it at the end here, this question of rising populations. As populations rise, we have to think about how to be more sustainable as a world, and yet we haven't really learned how to do that yet. So we also have to use all the techniques and technology that we can to monitor change, because the more we know about how it's changing, the more we can deal with what the impacts are. Well, let's look at some of the broader ways to deal with this. One is with trade. There was a very successful trade activity, a trade embargo on ozone destroying chemicals that were used in refrigerants and in spray cans as part of the Montreal Protocol against ozone, trying to protect the ozone hole against ozone destroying chemicals. And in fact, that trade embargo has been a huge help in terms of reducing the number of these ozone destroying chemicals. We need to have reduction of trade subsidies for dirtier industries. We have to recognize that most trade, about 90% of trade, 99% by weight, actually goes by ship. All these ships have to have coastal ports. Coastal ports are threatened by rising seas. And so you can see how these things are connected. Very important to protect the ports. So that's trade and climate. Let's look at the courts and the legal side, just to give you kind of a quick survey here. In April 2007, just by a 5-4 vote, the US Supreme Court said that the greenhouse gases could be regulated as a pollutant. And there's a really interesting book, if you're into this and how the Supreme Court works, called The Rule of Five, which tells how the advocates of this decision worked on the justices to make it possible to have something they could all agree on. It was a very focused decision, but it has been very, very effective in terms of reducing pollution. And just in this month, just a few weeks ago, Germany's highest court, the Court of Red Robes there, ruled that Germany's plan for reducing emissions wasn't strong enough. It wasn't enough to protect younger generations from having to do much more than they should have to do. Putting the burden of curbing CO2 on the young was not something that the court said was possible for Germany to do. So they ruled against that. So the courts are a very important part of this, this whole process, as is the public. There's been a protest and social actions, certainly since 2007, and really even before that, the 350.org Step It Up campaign. There was a mobilization for the Copenhagen Climate Conference, people's marches in 2014 and 17, divestment movements, the Extinction Rebellion, the Fridays for Future that Greta Thunberg organized. And in fact, there has been another one of those strikes in India just last month, and there was a global climate strike in 2019. So you're seeing mobilization against this. You're also seeing climate being discussed not just among the scientists or among the policy people, but in literature, music, and art. The Pope has an encyclical, How Humans Could Live with the Earth. We've got some very nice science fiction future stories about a wall around Britain that would protect them against sea level rise, but how you keep people out. A story about New York 2140 and having a sea level lapping up around Times Square, how people deal with that. There's a rising sea of climate change literature. You can see art now being made out of these various rising graphs. That's a picture in Time magazine there. And even if you can see that, The Fate of Rome, an interesting new study, taking climate change science and medical science, putting those together and going back and trying to really understand what happened with the Roman Empire in its final days. So where are we with public opinion? Yale has been running a program of climate change communication now for a number of years, and they say there are 6 Americas, sort of half and half. You've got 3 of these. In fact, it's about 72% cautious, concerned, and alarmed. Others are disengaged. But actually, for a country like ours, maybe that's not so bad. How do you share the responsibility? Well, if we look at who's put the most CO2 in the atmosphere, that's the United States. So we're the biggest polluter, if you want. We put the most CO2 in over history. Who's putting the most in right now? That's China. They're the biggest player. And who's number 3? That's India. So is it the countries that put the most in, or it's the countries that are putting the most in right now? It has to be some combination of these. And then we have to look to the future. If we look at Africa, you can see from the green that in fact, there's not much emissions coming from most of those countries, except for the one in purple there, right in the middle, Nigeria. By 2040, Nigeria is expected to be the third most populous country in the world after China and India, and it has a huge demand for energy, as you can see from that. In fact, there are 5 million Nigerians currently using solar power as a source of energy. Much more to be done there. So it's not just a question of cleaning up our own emissions, but trying to look at this worldwide. Well, let's just start to conclude here. Is there hope? Well, we've done a lot of things, big things before. We've electrified entire cities. We've built indoor plumbing. We've made the interstate highway system. We've built the internet. We've sent people into space. Do we have the will? Well, we have learned from COVID and other societal challenge, even with the anti-vaxxers. I think no one was convinced that we could move as fast as we did with a vaccine for COVID. There was a lot of disinformation about tobacco from the tobacco companies, and yet we really have started in a strong way to deal with the tobacco problem. There's a lot of disinformation about climate change, but as I mentioned before, 72% of Americans believe climate change is happening. So I think there's a willingness to try to move forward here. So let me conclude now with what you can do, because that's really what we promised here. And there's 3 different areas: personal, your own personal interactions; social, broad networks; and then institutional, cities, states, and governments. And here's an example. What Philadelphia is doing. I won't go into detail in each of these, but move the airport, charge people to drive in the city, get ready for climate migrants. Maybe you'll have people moving back from Florida into Philadelphia. Make a green tax abatement, build riverside buildings, lift them up higher. You can see there's a whole set of things that cities can do, and this could be adapted for Jersey City or other cities at the same time. What can you do? Whoops, I went too fast there. What can you do? Well, the most important thing in my view is to be vocal. Most elected officials don't hear from their constituents. So it's important to contact elected officials, ask them to support clean energy policies. If you don't do anything, if you do this, this is really important. Vote for candidates who support these policies. Engage your friends, talk to your employer, write blogs, spread the word. Maybe you even want to run for office. But being vocal and being noticeable and using social media in a way that is strong is really important, I think. What you can do in terms of energy, well, think about how you use energy. Can your school or home generate its own renewable energy? Maybe you could have one of these Brooklyn microgrids, maybe a solar water heater. Be more conscious with your thermostat. Turn it up or down a few degrees. Depends on how you're comfortable. Use public transport when you can. Offset emissions from your daily commute. Switch to a hybrid or electric car. Not everybody is going to want to do all of these things, but each step you take is important because it sets an example, not only for you, but for your children, for other people in your neighborhood. This is all critical. If you take a picture, here's this sort of thing: insulating buildings, eating food that is locally sourced, driving an electric car, maybe a Brooklyn microgrid in Jersey City. These are all things that can be done and can have an impact. I was just mentioning about food. Eating less meat, particularly eating less beef, is particularly good. Remember I said in the last lecture, if you looked at all the emissions from cattle, they turn out that the Republic of Cattle, if you want to call it that, is the third most impactful of greenhouse gas emissions from the methane that the cows burp up from rumination. Try to buy local produce, use your reusable bag, donate money to your local environmental organizations, and try to get your favorite institutions, whatever it is, your school or foundation or whatever, to divest from fossil fuel investments. So that's what you can do. Here's what you already did. You've already done something really useful. You bought a cell phone. Now, maybe you didn't think about that as something that was really good for the environment, but in fact, cell phones are an example of dematerialization of society, using less material. A cell phone replaces the camera, the portable radio, the newspaper, the telephone, the tape recorder. There are about 14 different things on this slide that take up to build and operate about 1,700 kilowatts of power. Your cell phone is only about 75. So when somebody says, well, you shouldn't have a cell phone, actually, you should have a cell phone because it replaces a lot of things that take up a lot of energy. Okay, that's what you should do. What did I do in terms of this? Well, no, I want one more point before I go to that. Just to give you a sense of some books that would be useful to read. This is a basic science from the Intergovernmental Panel on Climate Change. Here's what we know about climate change, and we'll provide a list of these to people. The latest in terms of climate discussions back and forth with deniers. Here's a nice book that Greta Thunberg and her family did about how you can reduce things. Here's a good book that Elizabeth Colbert did from articles in the New Yorker about geoengineering and how it can be dangerous. Bill Gates has written a nice book about very positive about technical solutions to climate disaster. And then the world's guru on transitions of energy has said, not so fast. We don't know whether we can really make it in time or not, because the history is it usually takes 40 to 50 years to make these transitions. So the faster we can do this, the better. And then if you want to read from someone who's really passionate about the climate change issues, take a look at Bill McKibben. He's written a lot of wonderful books. Here's Falter, one of his latest books. It's a good one to take a look at. Well, as I said, you can ask, what did I do? I made this presentation carbon neutral. And so that I didn't eject, or at least it was the total carbon that was put in the atmosphere was zero for this. This is kind of called net zero. What I did was I bought some carbon offsets. I figured out that it took me about 2 months. I'd been doing 5 talks on climate in 2 months, about 30 tons of carbon. For a typical household per year, if I took 2 months of work, that's like 1/6, that's like 5 tons. So I went on to the web, I found an offset company that had been validated, so they really do it. And I bought 5 tons of carbon, planting trees, reducing methane, and doing some of those things that have been talked about. And I got my certificate here. It cost me about $50. So I was paying about $40 per ton so that I could say to you, all energy related pollution created during the making of this presentation was neutralized through 100% renewable energy certificates from TerraPass. So at least it's equal, and it's all verified. So that's important. Well, let me stop here. We had a lot of examples, and I'd certainly be happy to answer questions.
We have a question. Jenny Meyer, who's on our board, has a question. When we talk about a price being put on carbon outputs, how much is this enforced?
Well, right now, we don't have enforcement on this in the U.S. Canada has a price in place, $26 per ton. It varies, but that's an average. It varies across the different provinces. And as I said, the European Union has a relatively low price on carbon. There is an active discussion going on now in the administration of of putting a price on carbon. The big question on putting a price on carbon is how do you distribute that price equitably? When President Macron of France tried to put a price on carbon, the people struck. In fact, this was the yellow vest rebellion in France. You know, every car in France has to carry a yellow vest as part of a safety factor, and so people put on their vests and they oppose that. But it is possible to have taxing and pricing that accommodates the needs of lower income people. You just have to put it in place. That's all.
Christina, could we ask Jim to stop his screen sharing, and then people could ask their questions directly? Maybe we could unmute people one at a time, you know, if they wanted to ask a question.
Okay, I've got the gallery view up in front of me now.
Great.
Sure. So if anybody has a question, you know, I think they can unmute themselves and ask it now.
Yeah, I think Peter had a question. I'm going to ask him to unmute. Peter, do you want to unmute?
I'm working on it. Okay, got it.
Yeah.
Okay, so it's a bit. Oh, we got another Peter.
Yeah,
Peter Zernis, go ahead.
A very interesting presentation. My question is, will we make it in time?
Well, I think this is the question of the age. Exactly. As I said, we have rapid technical development on the one hand, and we have the need for putting in massive changes in infrastructure on the other. It's not to say that we can't respond rapidly to changes. We did a rapid response during World War II, but in a sense, it was simply to build an army and to do various things. There was a focus. And whether we can do this rapid change on all of society to a new energy transition in a short time, I think that's the question. And my guess is that we will do a lot of that, but we will also get warming. And so by 2100, we'll have a warmer, wetter world. But we will also have a lot of adaptation. We'll have new technology. So we'll probably have some mix of these things there. But I think the more people who are aware of the timing issue, the importance of moving rapidly, the better. And it's important for our officials to understand that. And it's important for the government to support private industry to try to do innovations to put these things in place. The faster we can do that, the better.
One of the things that, that I see in the paper, they always keep talking about 2 degrees, 3 degrees more, 2 point something degrees and so on. I wondered if that is such an abstract way of trying to get the idea across that your city could go underwater. Perhaps, with your graphs and so on, they were helpful. We need perhaps more documentaries that would actually show what is going to happen, because my eyes frankly kind of glaze over when I see these couple of gradations here and there, because I can't really translate them into anything specific.
I know this is I think this is an important point. One thing, and then Peter will get to your question, but one of the things is just yesterday, the Greenland authorities announced that they expect that the melting of Greenland causes ice to crash into the water around the coast, that the tsunamis from the glaciers that are melting off Greenland are probably going to destroy at least half of the cities. They're not big, but the settlements and other places where people live in Greenland probably will get completely destroyed. Now that's something that's going to get your attention. It's these are small settlements, but it's an impact. And that one of the books I mentioned, New York 2140, talks about how people are living water that has completely covered Wall Street, and now it's lapping up against 42nd Street and Broadway. That's another thing that's really good. So some of these science fiction novels can really do that well, I think. But now, Peter, you had a question.
Okay, yeah. My question is probably longer than your answer will be, but here goes. The Times ran 2 recent articles promoting the theory that rapid population growth is essential to supporting a strong economy, specifically in the United States, and then another article a couple of days ago about China. There was no mention of the negative effects of overpopulation. It seems to me that Japan and other countries with slow growth are doing okay. Would you comment on the relationship of population and climate change and economies? Also, world population is projected to level off at between 8.1 billion and around 11 billion people. So growth will likely stop or even reverse in the next 50 to 80 years. What effect will that result have on the environment and on the idea that population, economic growth is essential to economies?
Yeah, well, that's a broad question.
Yeah.
And you can really think of it in 2 parts, really: economic growth and population growth. What we have seen in the population studies is that as a country becomes more economically productive, women have fewer children per person. In other words, the child number of children per family goes down to around 2, or maybe just a little bit less than 2. You see that in general around the world, and it's happened in almost every country in the world. You can plot economic development and standard of living versus number of children per family, and they all level off. So independent of the economics, that as I mean, not independent, but as standards of living rise, population growth goes down. So it's very possible that, in fact, the World Bank currently estimates that, as you said, that the population will probably level off somewhere around 2100, maybe 10, 11, 12 billion. The curve is already starting to curve over. But that means that everybody is using more resources if we continue the same kind of resource intensive economy. And the question is whether we can transition to an economy that is not so intensive on resources. We're learning how to do some of that. This is a sustainable economy, but we're still mining as much as possible. We're trying to take as much out of the earth as we can. We have to learn to do this. There are a lot of studies going on right now about how humans can be sustainable, but it means we have to live in a somewhat different world. There has to be more cooperation. There has to be a different way of living. We can't be so wasteful. We can't do a lot of the things that humans have done, not thinking about the environment, but in fact incorporating that into the way we think. I think it can be done. It's a big change, and it's gonna take people to really understand that. You know, just one example. China, at the time that Emily and I visited China, which was what, in the early 80s, I think. Yeah, we visited in the early 80s. You got people mostly on bicycles. And so my thought at that time was, you know, wouldn't it be wonderful if China could transition directly from bicycles to electric cars? Because if you could move all of the charging equipment, which tends to be more polluting, to somewhere outside the city, and you would have electric cars in your city, and you wouldn't have these huge pollution problems that you have in New Delhi, for example. Well, you know, China has a lot of issues in terms of development, and that's not something they did. They're doing it now. They're really trying to get heavily into electric cars, but that's just an example of what you can do. But it's all part of this question of sustainability. We have to learn how to be sustainable and to try to be less resource intensive. I don't think there's any fundamental reason that you can't have a society of 10 to 12 billion people that is not resource intensive and that is sustainable. We're a long way from doing that, but I think a lot of people care about it. And this is why I think when you look at what universities are doing, you generally see new institutes or new majors focused not just on climate change, but on sustainability. That's really the focus. Look at Columbia or Yale or Harvard, MIT, Stanford, Arizona State. Arizona State has a huge program just focused on that. So I think, I would kind of say your question is, can we become sustainable? And I think the answer is yes. And I think it's going to take a lot of education. We're sort of on the outside of it at the moment. Yeah, John. You're muted.
Oh, there you go.
Oh, okay. So I have two questions that are somewhat related, I think. And you touched on these in your talk. So how would you characterize the relationship between the scientific community and politicians in the administration or Congress? That's one part of the question. And the other part is, to what extent will government make important changes for climate, to respond to climate change? And to what extent is it the private sector that's going to be doing this?
Okay. There are some politicians who listen very carefully to scientists. There are some who only listen if there's a huge problem. I think we had a lot more politicians listening to scientists about the COVID than we have about climate change, for example. So I think it depends on the urgency of the problem and how you can make that connection. Typically, politicians don't really listen to scientists unless there is something that directly affects their economy. I had a long talk with Mark Sanford of it's South Carolina, right? Mark Sanford,
Yeah.
And he was not interested in the NOAA issues of coastal zone management until I talked to him about the fact that dirty beaches turn off tourists. And if you have clean beaches, you're going to do much better in terms of attracting tourists. And he got very interested in the whole question of clean beaches, which he hadn't been interested in before. Now, it seems obvious, I suppose, but politicians are focused on jobs and industries, and they tend not to think about that. But you have to make a connection. But my general experience is that most politicians are not really listening to science. They're more focused on other things, and it would be better to have people who are focused. Al Gore was very interested in science and talking to scientists, for example, and you have others. Sheldon Whitehouse in Rhode Island is very engaged, for example. Now, the second question was about government implementing science. I just
government response of government versus or together with the private sector.
Oh yeah, right. Well, the government and private sector do a lot of things together. The private sector wants to operate without any regulation and without any taxes. The government would like to see private industry operate within certain bounds and to pay certain taxes. But when push comes to shove, it really comes down to those points. And my experience is when I talk to people from industry and what is it you want out of this, they would say, well, we don't want to pay any taxes and we don't want any regulations. But if you're going to have to do it in a way that we can see benefits society, and don't keep changing them. This is one of the important things that private industry has always made a point of. We can live with regulation as long as it doesn't get changed. Now, of course, you can't have a government that doesn't change its regulations sometimes because times change. But to have shifting regulations is difficult, and most of the real experts and successful people from industry will say, look, you tell me what rules you want to operate on, I can figure out how to make money. Just try to do it. But in general, they'll push. But, you know, we have a very good relation between the private sector and the government in terms of providing weather services. The government does a basic forecast, and then all of these local weather stations and private weather forecasts take that and augment it with local observations, and they provide an even better local forecast. And so there's been a nice relationship there. And the same is true with energy and other things that can do. There's certain things the government can do that can help private industry move along, and private industry can bring along innovation and lots of new things. And then of course there are things that none of us quite understand, and we just try to get a handle on it, like the internet and the impacts of the internet on society. We're all trying to figure out, you know, what is that and how are we going to deal with it? And so it's, you know, it's an issue. But this is something that I think that has worked out reasonably well in the U.S.
I think Rob has his hand raised. Would you like to ask a question?
Yes, thanks, Christina.
You're welcome.
So first of all, thank you so much for the presentation. It's really enlightening and very helpful. I wanted to ask about, there are two documentaries, both of which I have seen, and I was curious if you had any comments on them. One is paints a very positive picture about the future. It's called Kiss the Ground. It's been up on Netflix, and it focuses on agriculture. I guess they call it regenerative agriculture. And you've made a mention to relating to no-till plowing. They seem to, it gives me the impression like that all by itself could be enormously effective in helping us with our situation in terms of sequestration. So that's question number one. The other one is a documentary called Planet of the Humans, which Michael Moore was one of the producers on. And that paints a very kind of negative picture about the clean energy industry, saying that it's really not, because of all the fossil fuel that's involved in creating these machines and whatever, that it's really quite wasteful and not going to get us where we think it's going to get us. So I don't know if you have any comments on either of those documentaries or points of view. I'd love to hear it. Thank you.
I know both those documentaries, and you know, this is a perfect example of why this is such a fascinating and important topic, because most of what each of these groups say is true. All of these things are happening at once. We don't know how they all come together. We do know, though, in terms of the agriculture, if you take agriculture and forestry, if you did everything regenerative agriculture, no-till plowing, you planted all the trees that you can plant, this does not solve the whole climate problem. It does not negate all of the fossil fuel emissions that are currently going. It's more like a 25% part of the problem. If you did all of these things that are talked about in Kiss the Ground and all the agriculture things that you could do, as I say, it's about a 25% part of the problem. It's huge because that's a huge part of emissions, but it does not solve the problem. But every little bit you do keeps some carbon from going into the atmosphere, and it doesn't last for 1,000 years there. So that's a good thing. The Planet of the Humans takes the kind of worst case scenarios and plays them out. And there are lots of disasters, you know, sea level rise and extinction and problems with ecosystems and in general. And you know, this is not impossible from the science that we know. Remember, trying to estimate what's going to happen in the future, there are two aspects to this. One aspect is, what are the emissions going to be? If the emissions are less than we currently expect, we'll have smaller effects. If the emissions are more, we'll have more. But it also depends on what we don't know about the science. The science of climate change and trying to forecast it involves understanding the role of clouds, of aerosols, of geography, of melting ice. We don't even really know if you warm up Greenland, exactly how the ice is going to fall off. It runs in rivulets and then there are little nooks and crannies, and it's very complicated. So there's an uncertainty in the science and there's an uncertainty in the emissions. If you take the worst case of each of these, yeah, you get the planet of the humans. If you take sort of the central case, you don't get you get severe effects, but not as horrible as a planet of the humans. And this doesn't take into account, on the one hand, the fact that we might have some very strong technical innovations that could really help us move quickly to renewable energy, or the fact that there might be some other problem that made things worse. So it's one of these problems that it's not a simple question of trying to build a device that's going to do something you couldn't have before, but it's bringing in all these social things. And, you know, if you looked at my maps there, you could see we have a lot of developing countries that want to raise their standard of living and they want to have energy. And if they don't get renewable energy, they're going to use coal plants or whatever. And China's actually been building some of these coal plants. So we have to find a way to get energy to those developing countries. And I would say that's something that really needs to be focused on. So not really a simple answer to your question, except that it really exposes the range of issues that you have to deal with. And I think it's important not to be too pessimistic about it, because there's a lot of things that we can do. It's just that we need to start doing them as soon as we can.
Thank you.
Are there any other questions?
I think Roger had a question. Roger, do you want to unmute? What about Jenny? Jenny, you had a question. You want to unmute?
Now I'm unmute. Hi. Well, I think I keep putting questions in. Well, I was going to ask about how much things had improved because of the disruption of COVID, whether that's been really measurable in terms of, you know, that we stopped driving and that we stopped, you know, commuting, and, you know, everything did kind of go online. If you felt that was significant and that, you know, has lessons in it. And I think my other question is, you know, since infrastructure is the big topic, and, you know, there's different definitions of infrastructure. If you were to choose something that, you know, if the administration could actually focus on it and get the support for it, what kind of infrastructure project do you think would have the most bang for the buck, or the most, you know, the most powerful?
Okay, well, you know, there are two questions. One was, could we see the impact of COVID on emissions? And definitely, I can't remember the exact numbers, but it was like a 10 or 15% drop in emissions. And, you know, the International Energy Authority and the US Department of Energy, they all track these things very carefully. We have satellites that measure CO2, so it's possible to get pretty good estimates of what's happening and measuring the emissions. So, you know, it's like a 10 or 15% drop, and it almost went right back up again after I think about well, 3 or 4 months, something like that. So, but you know, any drop is good, because, you know, as I said in the first lecture, carbon dioxide molecules last in the atmosphere for 1,000 years. So every time you take one of them out, and you didn't put it there, that's good. That's going to be helpful. And in terms of what the administration can do, it really, to me, that would be to stop burning coal. If you could shut down all the coal plants and replace them, find a way to replace them and to support the coal miners and provide energy, but just shut down the systems that are really spewing CO2 out into the atmosphere. You saw from that graph, it was expensive, but the number one effect was retrofitting coal plants. To have a crash program just doing that, I've always felt, did Biden have just 2 years before the Congress gets shifted over? If it did, I'm hoping it won't. But you've got that 2 years at the beginning. If you could spend that 2 years just getting rid of all the coal plants, that would be a fantastic first step. It's going to cost you something, but as you were saying, it's hugely cost effective because every CO2 molecule we don't put in the atmosphere, that really helps. And so that, I think that would make a strong statement. And it's very doable in technology. We know just what to do, so it's not that big a deal. It's a good question.
Jim, could I ask you? There are quite a few Parks Coalition people on the program, and I wondered if you could say something about the importance of trees and tree planting, because the Parks Coalition had an initiative with the city of Jersey City to it was called City of Trees, to plant many trees. We had a severe deficit in tree canopy in the city, and a local group has also done a recent study that shows that since this initiative began, we actually have fewer trees because the rate of loss of trees is not, being made up for in planting. So I thought maybe you could, talk a little bit about the importance of trees and reforest.
Yeah, that's a good point, Maureen. Trees are really valuable for cities for a couple of reasons. One is that they provide shade and keep the city cooler. This is something that is really noticeable in any city that doesn't have trees. So providing shade and keeping the city cooler is important, not just because it makes it pleasant to have a walk, but it means that you spend less money having to cool buildings with air conditioning. So it saves energy from buildings. And take a city like New York, 70% of the energy use is for heating buildings or cooling buildings, and then a large percentage, I don't know the number, is true in other cities. So to the extent you can have trees just for cooling, trees are also good because they put more oxygen into the atmosphere, so you've got a source of oxygen that is also helpful. So generally speaking, trees are valuable. They also, to the extent that you can get the trees to grow, they store carbon. So they're one more way of absorbing the CO2 from the atmosphere. So all of these are really valuable, but the insulating effect of trees and keeping a city cool has a direct, and I think it's the largest climate change impact there. So the more you can do, and what you've done with the embankment and what's being done with there's a huge number of tree planting programs in DC, for example, and from above it, large parts of the city simply look green. That has a huge impact on the livability of a city.
Thank you. Does anyone else have a question? Roger, you're unmuted. Do you want to ask your question?
Yeah, sorry. My question was concerning lithium and whether we could mine enough lithium here in the United States without having to depend on China and Chile for it, which is important to run these electric cars.
Yeah, I think everything I showed there, the airplane, the ship, the cars, all of these require lithium ion batteries today. They turned out to be the most energy intensive. And there was actually a long article in New York Times just a couple of weeks ago about the whole question, just the question you're raising about the need for lithium and where it comes from. We do have lithium mines, a pretty good source in the US, but how long is it going to last is a good question. This was, of course, one of the things that was on President Trump's mind when he talked about buying Greenland. Greenland is well known to have a lot of these kinds of metals under the ice, and so a number of countries and industries have been looking at Greenland for some time, saying, you know, we should. As things melt and ice melts and you can get it, we should look at that. But you know, it's a good question. I don't think we know the full answer to that question, because it may be that some other kind of battery technology comes along that is important, and maybe we have the metals for that, and maybe we don't. At the moment, I would say we have maybe an adequate supply of lithium, but if you really go to the full electrification of society, can you really get what you need? That's one reason I mentioned the Gravicity kind of battery, because I think part of this problem is going to get solved with other sources of batteries, other sources of electrical storage, either pump water that is pumped to a high point when the wind is blowing, and then it rushes down and gives you hydropower when the wind is not blowing. These water-powered batteries, or mine shaft batteries, or energy storage, I should say, not batteries. This is a huge area that there's a lot of innovation and a lot of thoughts about, but I think we do have to be concerned about lithium and its availability, and this whole question of rare earths being important for chips and so on is something that's an ongoing problem. So it's a good point to raise.
Any other last minute questions before we end? Oh, Barbara. I think you're on mute.
Unmute.
Hi. I was just wondering about the issue of climate refugees, and if governments are talking to each other about this in terms of future planning. Is our government doing like war gaming things? Is the national security apparatus involved with this? I mean, I'm just wondering to what degree we're thinking about what might happen.
Well, I would say parts of the government are thinking about this. I mentioned in the first talk that a National Security Council report came out in just last year, focusing on this question of climate migration and the fact that as developing countries were going to get affected by either increased or decreased rainfall and increased heat. And so the crop production was going to go down, or you had flooding, like flooding in Bangladesh. You were going to have to worry about climate migration. Unfortunately, the response of governments to climate migration as it has existed so far has been really negative. The Australians, when they saw that some of the island countries were threatened by sea level rise, passed a law saying no climate migrants. We simply won't accept any climate migrants. India has done the same thing against Bangladesh. And so what will we do if we have even more migrants coming up from the south? With legitimate reason, because there are countries being flooded or they've lost their agriculture because of climate. So I would say that our national security apparatus, certainly the National Security Council, is very concerned about this. How we can deal with it through the Congress and actually take account of it is going to be a real issue. In Britain, they're facing the same kind of problem with people who are essentially climate migrants coming up from Africa. Same in the European Union. And so far, I'd say the human response to this has not been a good one. But we're going to have to figure out a way to do it, because there are going to be climate migrants. There's just no question about it, because as you can see from that picture of the social cost of carbon, it's not Russia and Canada that are going to have the big problems. It's the developing countries in the tropics, and that's where the migrants are going to come from. How are we going to deal with it? I would say the national security part of the U.S. has been worried about this for some time and have public reports about it, but we've never really kind of laid it on the table and said this is something we've got to deal with. But you've identified a really serious issue there. Good point.
Thank you.
Ace?
Yeah.
Yeah,
Unmute yourself, Ace.
I think I did, right? Okay. Very last, very back local and weedy. I know a lot of people here, we're all for the trees. We all want to plant trees and grow trees. As fast as we can do that, the utility comes and destroys them. From your, and I always marvel, why can't we bury the wires like other advanced countries do? And I just wondered, from your, loftier perspective, carrots and sticks, one or the other. Do you see any policy or any movement towards that?
This is a really good point, Ace. The business, for example, of putting wires underground. Obviously, this is a big national security issue, because all a country had to do, and everybody knows this, it's not hidden, explode a small nuclear weapon high above the US is enough to knock out our entire electrical infrastructure, because it's all above ground, or mostly above ground. So just from a national security perspective, we ought to have this underground. And there are plans, in fact, that are being looked at. They haven't really been, accepted yet. But the idea of, I mentioned a national grid. Putting a national grid of wires that connects the whole country, but putting it under the interstate highway system, because you already have the right of ways built for that, so you could simply make this happen. It wouldn't be that hard in terms of a massive infrastructure bill, and hopefully this can come up in the current discussions. But I think it's a problem of cost and people not thinking about it, and not understanding the importance of it. And I think as we see how everything is interconnected, hopefully there'll be some interest. But the more people who push for this, the more likely it is to happen. But you're absolutely right. That's where we have to go.
Thank you.
Good question.
Yeah.
All right, I think any other questions?
I was just going to make a comment, if I may, about this problem with the trees that Ace raised. In DC, we've certainly had plenty of trees mutilated by whoever is hired by our power company to cut them back from the wires. A couple of times I've been able to get our own tree pruners to do it preemptively, but they're reluctant to do that because, in fact, they can be fined for doing it. However, what I've noticed most recently is that it looks as though the city is starting to hire people to do it before the power company does, the electric company, sorry. I haven't actually confirmed that that's the case, but that's what I seem to observe. And that might be something, because DC does, as Jim mentioned, have a very strong push for trees and trying to double the tree canopy, I think, which is already pretty good for a major city, or small major city. And so that would be something that your coalitions could try to take up with the city government to see
Good point.
if that was something that could be done, or even to try to work with the electric company.
Mhm. That's
Yeah,
good.
good point.
That's a good
If
point.
I can interject, this Mark Wesson, the city is not allowed to go near the wires by state mandated. So our maintenance department may not do that. They can take away limbs that are against your house or in this tree or in the street that are dangerous, but they cannot go near the wires.
Hmm.
The Shade Tree Committee is in the process of having meetings with PSE&G to discuss how they've been butchering as opposed to pruning our trees. And this has been an ongoing thing for so many years, but we are having discussions with them.
Okay, well, thank you for that comment.
It seems, that this is part of a big problem that we encounter, in that this seems a problem that local people working with city government and maybe with the state government could resolve. And yet it's so difficult because people have been working on this for years. There have been tree committees going back, that I was involved in 15 years ago. And then they're resurrected every few years to try to solve the same problem. And, Jim, so much of your presentation, was about problems that it would be even harder for the little people like us to solve, except for the one solution that you have, which is that we have to raise our voices and make the decision makers make the right decisions. It's hard. It's really hard to do that, even on fairly simple problems here in our locality, much less global problems. It's more of a comment than a question, but maybe you could comment on that.
Well, I've spent a large part of my life trying to figure out how to make things work in the science world. Where are the levers of power? Who decides what? How can you make a difference? And so, maybe a little bit of my experience. I mean, one thing I discovered, I was interested in trying to see if we couldn't fly satellites for oceanography, but then you have to find the money for the satellites. And so you go to NASA and you say, why don't you fly these satellites for oceanography? And they say, well, we don't have the money to do it. Congress appropriates the money. And so in kind of a truncated version of our lives, Emily and I moved to Washington, and I started to talk to Congress to try to find out who in Congress would provide money for NASA to deal with satellites. So I find out, I try to talk to these people, find out who are the people who make a difference. So, I think it's trying to understand how the levers of local government work and trying to get involved with that. And usually I found with the federal government that what people tell you from outside mostly is not true. It's not the way things really work. It's a combination of how the system works, who the people are, where the sympathetic people are, and where they aren't, and trying to do that. I think it's harder in local government because one person can control a lot of things, and it's generally more difficult to do things, I think, in local governments, just because things are kind of diffuse. But trying to find the levers, I think, is important, and sympathetic members, and trying to talk to them about the importance of issues. And a large part of what I learned was how to explain things in simple terms so that the person I wanted to make a decision could understand what I was talking about. And I think most of my time in Washington was really spent trying to simplify things in a way that you could make a politician understand what you're talking about, and to see that it was relevant. So, I have that that experience. I haven't had the experience you've had in the local policy world, but I think that's one thing that's really important is a simplified message that can reach a sympathetic person. That's really important. But messaging, I think you'll see this all the time in people talking about how to accomplish something, how to make a message. And that, I think, and I know your group has been involved with that, trying to work on the message and so on. But I think messaging is really important.
You did a wonderful job with the messaging for both of these presentations. I think the visuals were fantastic.
Oh, great, thanks.
I have heard comments and seen comments in the chat on both of them. And, so I thank you very much for being with us for this presentation.
Yeah, it's been fun.
And the first one. I think one other thing that people can do is to share this recording. We hope to have it up, by the weekend. As I said, on our website and on our YouTube, and we will certainly share it on our social media. And if other people could pass that along, that's another way of being vocal.
All of my son's friends are in finals right now, but they're all in. I'm making them all watch it. So.
Oh, make them
watch. We want to watch it. I'm like, good, you're gonna.
Yeah.
I suggest that everyone unmute themselves and we can all thank Jim for wonderful talk.
Good idea.
Thank you, Jim.
Thank you so much. It was really very fascinating.
Thank you. Thank you.
Well, thanks to Maureen for suggesting it.
And you went above and beyond by going carbon neutral there. So thank you for that too.
Yeah.
Yes.
I'm gonna buy into that.
Yeah.
Thank you so much.
Okay.
Well, listen, have a nice evening.
Bye.
Thank you again.
Yeah, bye.
Take care, everybody.
Thanks, Maureen.